All right, welcome back. It's Sully again. So today we're going to be on topic 3, lesson 3. It's called polylog, which has really nothing to do with what we're going to learn today. We're going to learn about interpreting graphs, the characteristics of a polynomial function. Remember, a polynomial function is any function that has degrees with it, x squared, x to the third, things like that, but we're not dividing by anything. All right, so just a x squared plus 2x plus 7, things like that. We're going to be able to generalize them. We're going to be able to sketch them. All right, we're going to find out if they have real or zeros from the graphs. And we're going to learn about quartic and quintic again. Remember, those are fourth and fifth. And like I said, we're going to sketch them. All right, so we're going to talk about absolute maxes, minimums, and extrema again. Remember, extrema is just a fancy word for the extremes, the max and the min. Last time we learned about relative max and relative min. Today we're going to learn about absolute. So over on page 197, in fact, on page 196, they had some data, and they found the regression equation for this data. So you can see the blue dots are the actual data points, and the black line is the equation, which they have right here. Now, we could have done that on our calculator, but they did it for us, and we've done it before, so I thought, we don't need to do that today. So let's talk about a few things. First of all, the degree of this, we can find it easily here. It's a fourth degree, but how does that relate to this? Well, we also know that when we have a fourth degree equation or polynomial, we could have 4 zeros. All right, now, we don't have to have 4 zeros. Like this could possibly meet higher, and we'll talk more about that as it is. But we have 4 zeros. Can't have more than 4 zeros for a fourth degree equation. If there was 5 zeros, this would definitely not be a fourth degree. We talked about relative mins and maxes. Those were the points like right here and right here. In that area, this is the highest point, y value, in this area. Now we know that the graph goes up forever and ever and ever, and goes up this way for ever and ever and ever. So it's not the greatest y value, it's just in that area. Likewise, down here, this is our relative minimum because in this area, it's our lowest y value. But over here, this is new. This is called an absolute minimum. All right, an absolute minimum because it is the lowest point on the graph. Now, we could have an absolute maximum, right? If our leading coefficient here was negative and the graph opened down, then we would have an absolute maximum. Can an odd degree equation, like a cubic, can it have an absolute min or max? No, it can't because odd graphs always start and end. Their end behavior are always opposite. Even graphs are always the same, so we could have one, but odd graphs are not. The other thing I want to talk about here is we have a fourth degree equation. And look at this. How many times does it go from decreasing to increasing, increasing to decreasing, decreasing? How many times does that change? It changes 3 times. Now, this is another way that we could possibly determine what the degree is. How do I get from 3 to 4? Well, I would add 1. All right. So if I add 1 here, I would get my fourth degree. In fact, go over to page 204. Write that down. There's some spot right there. We can estimate the degree by finding the number of changes in the increase and decrease and adding 1 to it. So, for example, this is a quadratic. Right? There is 1 change from decreasing to increasing. 1 plus 1 is a degree of 2. 1, 2. All right. Add 1, that would be 3. What's another way to talk about this increase, decrease? We could talk about relative or extrema, right? We have 2 extrema here, relative, but 2 plus 1. All right. How many extrema do we have here? We have 1, 2, 3 extrema. Add 1. It could be a fourth degree. 1, 2, 3, 4, add 1. This could be a fifth degree, all right? Doesn't guarantee it's a fifth degree, but it could be, right? And the reason I say that is cubics could look like this, right? We talked about those power functions, and the power functions really don't have any relative max or min, and this is increasing the whole time. All right, so those are a little bit tricky. That's why I was saying we can estimate it. All right, doesn't work every time Because this one, if I said how many changes does it go from increasing to decreasing, it would be 0, right? I have 0 changes. So let's look at cubics a little bit more. Here are two possible cubics that we could have. We always know the end behavior is going to be the opposite. So as I go to the right, it could go up. As I go to the left, it could go down. Or backwards, as I go to the right, it goes down. As I go to the left, it goes up. Remember, all of this is the same every time. We just have to find these two situations, all right? So let's talk about the number of intercepts. If it's a cubic, the most we could have is 3. So I could have it look like this, where it hits 3 zeros. 1, 2, 3 zeros. I could have it hit twice, right? I could have it go up like this, and it could kiss down like that. Now this is a very special case, all right? It's called a multiplicity. There's only 2 zeros, but at that one, there's a multiplicity. So let's say that was x plus 2. I would have 2 of those. And on this one, let's say that was x plus 4. I had 1 of those. So I have my 3 zeros. My 3 x's to give me my x squared. But when it is tangent like that, when it hits the x-axis perfectly balanced, it has a multiplicity, and we say it has a multiplicity of 2. All right? You could have a multiplicity of 8, 6, whatever. All right. So we could have it hit twice. We could have it hit once. That's like when it is increasing forever, right? Or decreasing forever. It hits only once. Could it have a multiplicity of 0? No, any odd function cannot have a multiplicity of 0 because it has to increase or decrease the entire time. There's no change in increase or decrease. So my range is always going to go from negative infinity to positive infinity. Okay? All right. Let's take a look at page 205. Let's talk about quartics. All right. Quartics, again, are 4th degree. Okay. So even degree polynomials, the end behavior is always the same. So as I go to infinity or negative infinity on this one, it's always going to go to positive infinity. On this one, as I go to positive or negative infinity, it's always going to go to negative infinity. It's always opening down. All right. Possible number of x-intercepts. Let's take a look over here. So I could have 1, 2, 3, 4, right? And how many extrema? 3 extrema, that's right. So I could have 4. Let's see, can I have 3? 1, 2, multiplicity of 2. So that's 3, right? 1, 2, 3, but that would be a multiplicity of 2. All right, so I could have 3. Could I have 2? Ooh, let's draw. I could have 2 multiplicities. All right, so there'd be a multiplicity here. There'd be a multiplicity here. That gives me my 4th degree, but it has just 2 unique zeros. Could I have 1? Well, in fact, if you remember x to the 4th, that power function, we had one where it came in real close and it was just like that. All right, and that would be a 1. That would be a multiplicity of what? 4. The same 0 4 times. So we could have 1. And could we have 0? Yes, we could. We could have it such that our graph never touches the axis on this. All right? So the number of possible extrema, we could have 1, 2, 3. We could have 1, 2, 3. We could have 3. We could have, over here, we have 3 again. We could have 1, or we could have 0 possible extrema, right? All right. Let's go down to quintics. Quintics are 5th degree. All right. Hopefully by now you're figuring this out. Possible, as I go to the right, I go up. Or as I go to the left, I go down. These are range, all real numbers, right? Here, I'm going to the left, I go up. Oh, as I go to the right, I go down. As I go to the left, I go up. All right, possible extrema. Let's see here. We could have 1, 2, 3, 4, 5. Boom. Let's see if we can do 4. 1, 2, 3, 4. But that's because it's a multiplicity there, right? Let's see if we can do 3. 1, 2, 3. I don't think I can do 3 that way, right? But maybe think about it this way. 1, 2, 3, and then have it over here like that. That there would cause a situation where I have imaginary numbers. So I could have 3. And that works up here too, right? So while we had we had it over here, we could also have come here, and then, oh, those zeros don't touch. I would have 2 real zeros and 2 imaginary zeros. Imaginary zeros always come in pairs because we have a negative number, a plus or a minus negative number, okay? So we could have 3. Can we get to 2? Let's see. I could go up, come back. That's 2. Maybe do something like that. I could have some imaginary, some real, multiplicity there, right? All right. Could I have 1? Yeah, we could have 1. Something like that, where it only touches in one spot. Is it possible to have 0? No, we couldn't have any. We couldn't have 0, could we? All right. So possible extrema. We could have 0 extrema, though, if it was just a very flat one like that. We could have 1 extrema. See, this is the great thing. It's going to be all the way till what? 1 less. So I could have 1 less, right? All right, on page 207, we're going to look at this graph and answer some questions. The first question, let's look. It's the degree is odd because the end behavior is opposite. I know that's question B, but it's good to know. And the reason I do that, now the A value, remember the A value is in front of whatever the highest degree is. So let's say this is a 5th degree. It would be, let's see, it's increasing, so A would have to be positive. All right, could this be a cubic? Well, if it's a cubic, that means it has at most 3 zeros. How many zeros does it have? It has 1, 2, 3, 4. So it cannot be a cubic, can it? No. Too many zeros. All right, state the domain. Well, the domain goes forever left and forever right. So we could say negative infinity to positive infinity, or we could just say all real numbers. And again, any odd function, odd degreed function, is going to have that situation, all right? State the range of this function. Well, it goes down forever and it goes up forever, so all real numbers for the range as well. All right, let's take a look at relative extrema. Determine the number of relative extrema. Well, are there any absolute extrema? No. So how many relative extrema? We got 1, 2, 3, 4 relative extrema. All right, that means if I add 1 to that, it's probably a 5th degree. It might not. Absolute, we said there were 0 absolute extrema. And then I want to know, where is it increasing and where is it decreasing? Well, let's go back up here. So right here, the extrema is where it changes. So I'm going to estimate. So this is, I'm going to say this is negative 2.5. This is negative 1. I'm going to say this is negative 0.5, and this is an x value of 2, just approximate, and this is an x value of 3. So where is it increasing? Well, it's increasing from infinity, negative infinity to negative 2.5. From negative infinity to negative 2.5, it's definitely increasing. Then it decreases. Then it increases again from negative 1 to negative 0.5. Then it decreases. Then it increases from 2 to infinity. All right? That means it's going to decrease right here from negative 2.5 to negative 1. And decreases here from negative 0.5 to 2. All right? That's where it's going to be decreasing. All right? On page 208, I want you to stop the video and I want you to try this yourself. All right, let's try these. So what's the A value? Well, it opens down. That means it's a negative A value. The leading coefficient's negative, so it opens down. Is it even or odd? The end behavior is the same. That means it's even. Could this be a 6th degree polynomial? Well, I have 1, 2, 3, 4 zeros, so it could be a 4th degree. If it can be a 4th degree, it can be more. Let's look at the number of extrema. 1, 2, 3, 4, 5 extrema plus 1 more. Could be 6. All right. State the domain. It goes forever to the left, forever to the right. That means it's all real numbers. The range, though, goes from negative infinity to right about here. I called it 2.5. Again, an approximate. All right. Number of relative extrema, I had 4 and 1 because this one right here is an absolute max. It's an absolute max. These other 4 are relative. They're the highest or lowest in their area, but this one is the absolute. And then increasing and decreasing from negative infinity to 2.5, negative 2.5, from negative 1.5 to 0.5, and from 2 to 3. Those are all increasing, going up. Decreasing from negative 2.5 to negative 1.5, and 0.5 to 2, and from 3 to infinity. Okay? All right. Just a real reminder here. Nothing major. We've already talked about this. But essentially, if you have a linear, you could have 1, 0, right? If we had a quadratic, we could have the following. We could have 2 distinct zeros. We could have 1 0, but it has a multiplicity of 2, meaning the answer would be like this, x minus 2 squared. I have 2 of them right there. We could also have 2 imaginary numbers, because remember, the quadratic equation says I take the plus or minus of a negative number. That's why imaginary numbers always come in pairs. And on a graph, that means it doesn't hit, all right? And when we look at cubics, it's very similar. We could have 3 real answers. We could have 1 where it just hits there, goes forever. We could have 2 real solutions. This is a multiplicity of 2 here. We could have 1 real and 2 imaginary where there's a dip there. And that's because, again, imaginary numbers always come in pairs. All right, let's put our knowledge to the test here on page 213. We're going to sketch it. The sketch means it could be a lot of different things. All we're saying is it has to include these 4 things. So let's talk about this. Degree 4, that means it's going to be even. So it's either going to both go up or both go down, correct? A value less than 1, that means it's negative. So that means it's going to open down. A relative maximum at negative x equals negative 4. So I'm just going to come over at x equals negative 4. I'm going to make some point a maximum. That's going to be a relative maximum. And at x equals 3 is absolute. So it has to be higher than that one, right? All right, let's draw it. Degree 4. Here we go. Coming up. Now, I'm just going to do this and go back down. We have 2 real zeros on this one. I could have come down and crossed and had 4 real zeros, but this also counts. I have 1. Oh, man, that was terrible. This is to be a relative max here. Sorry. I could be like that. I have 1, 2, 3 maximums, or excuse me, relative extrema, 1 absolute extrema. So I have 3 total plus 1 fourth degree. Does yours have to look exactly like that? Absolutely not. This part matters. The fourth degree matters. That's it. All right, let's look at this one. Always increasing, so it's always going this way. That means it's got to be a power function. All right, meaning like I don't have any twists and turns. The y-intercept is at 5. And the x-intercept is at negative 1.7. Now, I could have a straight line through these 2 points. I could have a cubic or a power function of anything. Just depends on what you're feeling. All right, I'm going to put a little kink in it. All right, that one's not terribly fun. All right, so what I want you to do is I want you to try C, D, and E. All right, now I'm going to give you a hint on page 214. They're not all possible to draw. So if it's not possible, I want you to make sure you tell me why it's not possible. All right, so if I look at the first one, add degree. So I start looking like this. Increases to negative 3, then decreases to positive 3. An absolute maximum at y equals 4. Well, guess what? You cannot have an absolute maximum when you have odd degrees because they go forever down and forever up. They increase and decrease forever. So the range is all real numbers. So there'll never be an absolute. All right. The end behavior here I notice is the same. So it's even and they're both going to the positive infinity. So they're both going up. All right. I have 4 x-intercepts. I started and drew those. Realize I screwed up badly. Relative maximum at 3. So I came down here. I drew it in here. came back up. At 3, I kind of came back down. That's where I was like, oh, that's ugly. But it is what it is. All right, that one works. You could have something a little bit different. Down here, I plotted my zeros. I have 3 zeros, which means I'm going to have at least a cubic. I could have a quartic, I could have a quintic, I could have any higher number, 3 or higher, but I cannot have a degree less than 3 because I cannot have more zeros than my degree number. All right? All right. It's that time for you to practice. So on page 215, all right, I want you to go do the practice. 215, 2 and 3, and then on 220, number 2. I think there's multiple parts on part of these. That's okay. Do your best work, and make sure you ask lots of questions. Till next time. Peace.